Hello everyone and welcome to Electron Empire. In this fourth episode of Know Your PC, we'll talk about one of the most important components in a PC, the graphics card. We'll talk about the ins and outs of a GPU and explain all the specifications. Don't forget to subscribe if you want to learn more about PCs. The role of a graphics card, also called GPU, is easy to understand. As its name says, it's what will draw the image on your screen and will calculate most graphical related things such as light, grass movement, animations, etc. The two main producers are NVIDIA and AMD. Unlike a CPU which has a few cores and high frequency, a GPU will have a huge number of weaker cores to process as much operation in parallel. There are multiple factors for this, the main being clock speed, VRAM and cores. The clock speed is quite similar to what is said in the CPU video. It's the number of operations a GPU can do in a second. For example, a clock speed of 2250 MHz means that the GPU can do 2.25 billion operations per second. Let's talk about the cores. There are two different names for the cores. NVIDIA calls them streaming multiprocessors and AMD calls them compute unit. We'll simply refer to it as cores for simplicity's sake. Shaders units, called CUDA cores by NVIDIA and stream processor by AMD, are what will be used to allow efficient parallel processing. They are what is the most comparable to a CPU core, but they are counted in 100 in a GPU. Tensor cores are NVIDIA-only technology. They are used for AI purposes such as DLSS and frame generation. We'll talk about that later. RT cores are also NVIDIA-only technology, and they are what will be used for ray tracing, which is a technology that improves lighting effects and reflection in-game. AMD made an equivalent for RT cores called ray accelerators, even though they're slightly worse. All of these cores are part of streaming multiprocessors or compute units, and the more you have, the better. VRAM is similar to the RAM, but it is what is used in graphics cards. It will store every asset the GPU needs to smoothly render frames. The three latest generations of VRAM and what's mostly used in modern GPUs are GDDR5X, GDDR6 and GDDR6X, the GDDR6X being the fastest. Nowadays, I do not recommend buying a GPU with less than 8 GB of VRAM. Before we continue, there's one thing I'd like to clarify, is that while NVIDIA and AMD make the actual chip, the GPU you buy is not always entirely made by them. Some brands, such as Asus or Sapphire, are GPU manufacturers. They will make things such as the design of the card and have all the cooling, but the chip itself is still made by NVIDIA or AMD. In some cases, the card is also manufactured by the chip maker, such as NVIDIA Founders Edition cards. GPU names are pretty easy to understand. We'll talk about both NVIDIA and AMD. Here are some examples for NVIDIA. The two first digits defines the generation, 20, 30 or 40. The two last digits are what define the power of a GPU in their generation, the 90 being the highest and the 50 being the lowest. The TI after the name of some cards are here to show that the card is more powerful than a non-TI card but less powerful than the one above. For example, a 3060 Ti is better than a 3060 but weaker than a 3070. If there is a super after the name, it is similar to TI, but it is in between the non-TI version and TI version. For example, a 4070 Super is better than a 4070, but weaker than a 4070 Ti. In the latest generation, NVIDIA also released a card with both TI and Super labeled on it, the 4070 Ti Super, which simply means it's slightly better than the 4070 Ti, but weaker than the 4080. Let's talk about AMD. It's quite similar to NVIDIA, but this time only the first digit is for their generation, 6 or 7, and the second is what defines the power of the GPU in its generation. The third digit is either a 0 or a 5, whereas the 5 is better. A XT after the name is similar to NVIDIA's Ti, and the XTX is actually only reserved for the best AMD card, the 7900 XTX. A GRE after the name is quite rare, but it is similar to the non-XT version. The DLSS and ray tracing are NVIDIA technologies that allow multiple things. First, the ray tracing will be used to create better lighting effects and reflections as said earlier in this video. It only works with NVIDIA RTX 20 series and more. Most of the times, NVIDIA RTX GPU will be better at ray tracing than AMD. Secondly, the DLSS will be used to upscale the image so you get more FPS in a higher resolution. For example, when playing in 4K, the image will be calculated in a lower resolution and then be upscaled to 4K with AI, which puts less strain on the GPU and improves FPS. AMD has an equivalent to the DLSS called AMD FSR. The frame generation is, as the name says, something that will use AI to generate frame that will be put in between the real frame, which results in an overall FPS boost. AMD recently released what's called fluid motion frames, which is basically an equivalent for AMD cards. It can be interesting to note that while DLSS and frame generation are only for NVIDIA RTX GPUs, AMD FSR and fluid motion frames works on most of the recent GPUs, no matter what the brand. Let's finish with the architectures. The architectures are basically what defines the generation. For example, every AMD 7000 series GPUs are based on the RDNA 3 architecture. That brings us to an important subject. How to compare GPU that doesn't have the same architecture? Well, looking at the cores and frequency can help, but it's not what will be the best. There is no direct way to compare, and the best way is simply to look up some benchmark of the GPU on Google. Also, a general rule of thumb that can help is to retrieve 1 to the second or third digit when you go up a generation, and sometimes retrieve the XT or TI. For example, a 4080 is roughly equal to a 3090 Ti, and a 7800 XT is roughly equal to a 6900 XT. It doesn't work with everything, but it's a nice thing to know. And that finishes this video on graphics card. Don't forget to subscribe and like if you found that video interesting or helpful. That was Electron Empire, and see you next time!